Hello everyone and welcome back. In this video we're going to talk about determining the sample sizes for means, just like we did for proportions. If we have an idea of the margin of error and a confidence level that we wish to achieve, then we can rearrange the margin of error formula to determine the sample size that is needed. So after some algebra, we can determine the sample size by taking the critical value over the margin of error squared times the standard deviation squared. Now looking at this equation, we need the standard deviation. We can guess this value or we can obtain an estimate from a small pilot study. Now we also need the critical value. However, this requires us to find the number of degrees of freedom, which is n-1. But there's a catch-22 here. In order to find the critical value, we need the number of degrees of freedom, which is n-1, but we need the sample size to find the degrees of freedom, which is what we're looking for. So a common approach is to use the critical value that comes from the normal model instead. So if we were to replace the t critical value with the z critical value from the normal model, we can calculate the sample size by using this formula. And if the estimate is 60 or more, then it's a good enough estimate. However, if it is smaller than 60, then we can add another step by recalculating the sample size again by using the first estimate, n, using this formula, which can then give us our degrees of freedom in the original formula. And once we have the estimate of the degrees of freedom, we can find the critical value and then recalculate the sample size once more. So now let's consider the following example. The manufacturer of official NFL footballs uses a machine to inflate its new balls to a pressure of 13.5 pounds. When the machine is properly calibrated, the mean inflation pressure is 13.5 pounds, but uncontrollable factors cause the pressures of individual footballs to vary randomly with a standard deviation of approximately 0.1 pounds. So for quality control purposes, the manufacturer wishes to estimate the mean inflation pressure to within 0.025 pounds of its true value with 99% confidence. So what sample size should be used? So we're given that the standard deviation is 0.1 pounds. The margin of error we want to achieve is 0.025. And the last thing that we need is the critical value that corresponds to 99% confidence. Now recall that the t distribution is exactly normal if we have infinite degrees of freedom. So we can actually use the t-table to find the critical values for the normal model. At the very bottom of the t-table gives us infinite degrees of freedom, which corresponds to the critical values of the standard normal curve. So for 99% confidence, the critical value is 2.576. So now we can determine the sample size. So we take our critical value of 2.576 and divide it by 0.025. That is all squared. And we multiply that by 0.1 squared. And this will be approximately 106.17 and so on. Now we can't sample 0.17 of a football, so we're going to round up to the nearest integer. And so the sample size should be at least 107 footballs. And so this will conclude our lesson for this video. In the next video, we'll talk about the one sample t-test, and I'll see you then.